to kind of kick us off, I'd love to invite Art Thompson and John Wells from Sage Cheshire to stage. You got to see them yesterday, and hopefully some of you talked to them last night at dinner. But as you know, they have over 40 years of experience in design, engineering, research and development, and prototype or even finished production. They've worked on really cool products and projects that you're going to get to see today. So I'd really love to have Art and John join me on stage. Welcome them. Gentlemen, good morning.
Yeah.
How are you?
Good.
Good to see you, John. Thanks for coming. I'm going to give you the clicker. You get to drive your slides. I think you got a video to kind of kick us off.
So I think what we're going to start with is to show you one of the little projects that we worked on that many of you have seen. So we'll start with that. Yeah, a little bit crazy. We're kind of a weird and unusual group, very eclectic. We actually have 3 different groups under one house. Sage Cheshire, which we do aerospace work for a lot of major aerospace companies, Northrop, Boeing, Lockheed. We make missile avoidance tail cone sections for Gulfstream. The thing Sage Cheshire is most known for, obviously, is Red Bull Stratos, where we caught the attention of about 3 billion people, so that's pretty cool to catch about half the world's audience. Wow. A to Z, which is our group that does specialty vehicles, special effects, movie vehicles. We did the Batmobile and Freeze-mobile for Batman and Robin, a number of different movie things. We also do the can car for Red Bull, so everybody knows the can car driving down the street. I always find it funny to be with NASA folks and was on a job getting off the freeway. And the first car we see drive by is a can car. And all the NASA guys are like, Art, what is your car? So unusual kind of group. We do a lot of product development, creation, a lot of on-the-fly design. And then Emery Motorsports is our group that we do Porsche restoration. So we restore old 356s, 904s, 908s, some of the rarest Porsches. And I'll talk a little bit about how HP comes into a lot of solutions for how we process a lot of that information. Working with the Z Workstations, computers have changed over the years so much. When I first started with Red Bull Stratos, it was in 2005 when I went to Austria and kind of proposed the concept of how we were going to break Joe Kickinger's record, who did it in 1960. He jumped from 102,800 feet, going 614 miles an hour in free fall. And over the next 53 years, nobody was able to break that record. And many people died trying, because it's a very hostile environment. Well, in 2005, when I first proposed it to Red Bull, computer systems have still been evolving. And in 2007, when we actually started the program, when we got the green light, We started out by doing design work and CFD analysis, looking at what happens to a human body falling from near space. And so developing CFD analysis, fluid dynamic modeling, it's very number intensive. You know, there's a lot of data. And so we create these models and ended up handing them off to universities. It would take a couple weeks to process the data. What's fascinating to me over the years, eventually, you know, we started doing it ourselves on our workstations at our office. And what's really fun to me with partnering with HP in a lot of things is to look at the processing power today of the Z workstations. It's incredible. You know, what we used to wait 2 weeks for in 2007, we put a CFD analysis on, and 5 minutes later, I have the results I was looking for. 5 minutes. You know, I mean, it's incredible. I can tell John and say, you know, let's pull up, you know, Felix in free fall at whatever altitude and speed, and we'll pull it up on the computer, and John and Nick and the guys will pull it up, and literally within 5 minutes, sometimes less, you're looking at computer flow, you know, and it's amazing to see. You know,
allows you to iterate the process a little bit more, sounds like.
It's more fluid on our work process. Our creativity is not paused by momentarily waiting for results. It's just stepping from one instance to the next.
It keeps the process very fluid.
Yeah.
So some of the things, you know, this is a picture of the inside of the capsule, which is fairly complicated. We realized when we started this program that normally the electronics on a space capsule is not exposed to near space environment. Usually the air draws the heat off your circuits, and so we actually were the first ones to develop a solid state circuit breaker, which could operate from the ground base as well. Our pressure capsule operates at 8 psi, which is 16,000 foot equivalent. So Felix rode 2.5 hours up to 24 miles up in the stratosphere at 16,000 feet. Joe Kittinger, when he rode up, it was in an open basket. And so the environment, what he jumped through was actually minus 95 degrees Fahrenheit. So colder than dry ice in free fall. It took 4 minutes and 20 seconds during the free fall. The entire time to the ground was just under 10 minutes. But this is some of the things, is developing this on the fly. We're building as we're developing, as we're designing. The hingeless door system, which I came up with, was a system for sealing off the capsule that NASA's looking at.
Everything we do in our shop is engineered, tested, designed, built, everything in one location. So we have to go through and have all the computers that we need to do the engineering in it, as well as the network to the CNC end, where we have all of our CNC equipment.
Wow.
And we've taken the Z230s for some of our CNC equipment, the Z420 for the engineering office, and we've really gotten to push our abilities in using those machines.
It's fantastic.
Yeah, so we're operating our gantry mills. We have gantry mills that are 11 foot X, 20 foot Y, 4 foot Z, with 220 on the U. We've got CNC.
Hot wire, the hot wire is a 5 foot by 10 by 16 foot 5 axis. So we can actually cut out a lot of shapes that simply aren't practical for other machines.
Yeah, CNC.
A real man shop.
Yeah, it's definitely a toy store. You definitely have to come by and see it, because there's CNC lasers and plasmas and water jets and hot mills. So we do a big variety, and it's not just the machining.
We get to do a lot of this engineering analysis, like the CFD for fluid flow. On the screen here, you see the fluid flow of the capsule in descent, and we want to make sure it wasn't going to go into a spin, and it did. And now we go back and reiterate and take our test results and find out why did it work that way.
And what applications are you using on that?
SolidWorks we're using for the CFD plugin. We also use SolidWorks for the thermal analysis to make sure that if it's negative 95 degrees Fahrenheit outside, how cold was Felix going to get? We only got to positive 45 degrees Fahrenheit coldest on the inside.
In the capsule.
Wow. So we had to
It's
remove
a
thermal
good
management.
environment. Yeah, so, you know, with the thermal analysis also, running all the modeling on the Z workstations, we're able to look at not only the structural also the thermal analysis for what the materials are going to do at a near space environment. So it really gives us a lot of computing power of being able to work and build while we're talking. What I love is, in the old days when you'd see the hourglass and you'd be in the middle of trying to explain and discuss something. Now it's really fluid. Everything flows really good. We have the guys in the room, and as we're designing and thinking through the process, we're moving things around in real time.
Well, the earlier generations of computers we're using, you'd always just put the panels or subsections together with no fasteners. That way you could show the general view. Now we can actually go through and put out the whole bolt assembly and everything on there, so they can see why is it holding together, where's all the fasteners, the stress points,
Fantastic.
all the details.
So this is the modeling for the capsule, showing the structural frame with the sphere, which is basically the egg in the basket. We had to go through and design out the crush pad assemblies to absorb the impact, because these parts are all reused. We did 2 unmanned flights and 3 manned flights. The 3 manned flights were to 71,000, 98,000, and 128,000 feet. So you look at, thinking about somebody going over 1,000 kilometers an hour in free fall, it's pretty fascinating.
The thermal analysis we really had to use for electronics. We had 1,200 watts just of camera system recording and transmitting for the ground for everyone to be able to watch it live on the Earth. And we only had 0.2% atmosphere for all the convection. So thermal analysis was really one of the core problems we had to take care of. And this system here is a aluminum pressure housing with 1,200 watts of camera recorders for all the HD cameras. We had 18 high-definition cameras on the capsule, all being controlled by one unit.
It's operating for 5 hours, so we had 80 watts at 5 hours, which is a lot of power.
Sure.
We used to call this Nomad. I don't know if people who know the old Star Trek. There was an episode of this thing that hovered around, and it would send out lightning bolts and kill you. And so when we'd see them loading Nomad, it's like, okay, because it's like nothing but raw power. So a lot of the things, being able to work on the fly, doing the fluid dynamics, really interacting on the design aspect, and not having to worry about the computer. That's one of the things that we really love about the Z Workstations. It makes the whole process so smooth and easy. It's like they always say, when you get something wrong, everybody is there to tell you about it. When something's working right, it's like nobody discusses it. So for us, we never talk about the computers.
That's a good thing.
That's a good thing.
Chest pack, we went through a lot of iterations. We had to be able to make sure it fit Felix, where you can see around it, operate around it. We had 4 GPS units, 2 accelerometers, 2 battery packs, dual comms to the ground. That way he can talk to us and we can talk to him during the free fall. Also a umbilical cord to connect to the capsule. Is in the capsule, use the capsule radios. There was a lot of engineering went into that. I had to model every component, be able to rotate it around, show everyone, okay, this is where we're putting this is how we're fabricating it, hand off to the machinist to build the parts.
Yeah, so this is just basically his chest pack, and we're having dual communication on a little handheld radio, and we had high gain antennas that we're tracking with the camera trucks. So we were able to actually talk to Felix in free fall at over 65 miles away, which is pretty cool. And it has a little GoPro camera on the top, and it's got GoPros on the leg. So we're able to, some of the greatest footage was from that. Here's the capsule and the crane getting ready for flight. And you can see these big camera pods hanging off the side. So that was a concern in fluid dynamics to understand if it was going to propeller or if it was going to porpoise and free fall. Capsule came down at over 400 miles an hour in free fall too.
And it's still in one piece.
And still in one piece. Yeah, I mean, the toughest part of the capsule was going from when it landed on the ground, when it was loaded on the truck, and going back to the hangar. That was the worst part, When it landed, the thing was in beautiful shape. It's like, okay, let's see if it's that way when it gets back. Because some of those guys would be off-roading and jumping over stuff, and it lands in a lot of remote areas. This is actually manned flight 2, so this is the 98,000 foot flight. We went 30,000 feet higher than this, but I love this picture.
It's beautiful.
Sage Cheshire, we also do, this is X-37, which is a low orbital satellite placement vehicle that's gotten a lot of publicity flying out of Vandenberg. With the pylon support, the other piece that's hanging under the B-52H and a mortar tube assembly. So we do a lot of things for NASA, and again, being able to run through and rapidly create things. A lot of the major aerospace companies come to us because we can do things very quickly. We don't have a lot of bureaucracy. We're a very small group, and we can react fast, we can build fast. So that's kind of the interest in working.
Everything from Red Bull cars to...
Yeah, it's a little bit crazy. When people come through the office, we call it the revolving door. It's like, everything's mixing up. So we go from aerospace to movie. This is actually F-35 for Live Free Die Hard. So this is the plane that chases Bruce down the freeway, Bruce Willis. And so it's going back and forth. But what I find is that by being very eclectic, it allows us to stabilize the workflow. We have, some of the top guys, and for them, the variety of work gives them a really good feel for moving around into different things. This is Total Recall 2012, the hover car. That's our gantry mill, gives you kind of an idea of the size. We're able to do quite a number of things with it. This is Mr. Freeze. So Arnold, he's got one of these suits in his office in Santa Monica. We built 18 of these suits, as well as the Batmobile and Freeze-mobile. I've got 2 of these that I haven't put together yet, one of these days. But going back to the computer modeling, we have scanners, white light scanners and laser scanners that we use for collecting data and information. And a lot of that is being able to collect for rare cars, because we do restoration of very rare Porsches, and the right side is not like the left, and the front is different than the front of the car that was built right after it. And so collecting that data and being able to get that fingerprint of what you're building. So we go out in the field with our scanners, and we'll scan a vehicle or a boat or whatever, in this case a Porsche. And having the ability to do that, we went out and we needed a laptop that had some computing power and actually pulled off the shelf an HP laptop specifically for that, because it was capable of handling what we needed. So from this, we can CNC machine female bucks or whatever.
And I can't wait to work with the new mobile workstation.
Yeah,
So much more
definitely.
powerful it is than our previous Hewlett-Packard laptop.
Yeah.
Nothing like having
You want to take one of these?
Well, when are people not going to be working?
That's right.
So, from the data that we collect, then we go out and we create female bucks for building interior sections, or male bucks for building the exterior roof sections. We CNC machine full-size masters, so this was cut on the full-size mill, to really guide us through the fabrication of all parts and pieces. And then we roll form. This is hand rolling on an English wheel aluminum body panels. So we're kind of a strange group that you normally don't see a group that does composites, thermoforming, and roll forming of aluminum and structures and aircraft.
Reminds me a little of the other John Wells of Morgan.
Exactly, that's what I was going to say. When you introduced John Wells the other day, John's out there somewhere, I was like, looked over at John, I'm like, when did you go to work for Morgan? I thought he was moonlighting on me or something, so that was pretty fun. So these are some of the cars, they're definitely a step above. Rod, my partner, Rod Emery, his grandfather was Neil Emery, Valley Customs, who was noted for being the first hot rodder to section and channel a hot rod, which is pretty significant. It's very cool. So Rod grew up around that hot rod kind of mentality and started a group called the Outlaw class of Porsche, which some people see as sacrilege because you're taking an old car and doing modification. But, Rod, and my philosophy is that if Porsche were alive today, he'd be doing it. So we do things like we'll take the 4-cylinder Porsche motor, we scanned it, And then CNC machine, a brand new 4-cylinder block. And we take all the guts out of a 911 6-cylinder Porsche overhead cam, and we put that into the 4-cylinder Porsche motor. So we take, instead of a 110 horsepower motor, we put a 220 horsepower motor in these cars. So the next thing we did was start breaking CV joints, and so we make that stronger. And so
You guys have way too much fun.
we do have a lot of fun. I mean, you know, some of the things like the 908s and 906s, we actually have some of the original tooling. So when people go to restore these cars, they come to us.
Wow.
You know, so it's kind of nice. Then there's A to Z. You know, there's something really enjoyable about cutting the roof off of a brand new car. You know, so my guys consider this therapy. The upper left section is a rendering of the car, of the Mini Coopers. And so we've done over 800 vehicles for Red Bull over the years, from Mini Coopers to pin scours and sport tracks. And it's fun to see, like I said earlier, everybody recognizes the can car, which is neat. You know, people are always fascinated with it, and we've built a lot of them.
Wow.
The Hummers, we do these for Mexico. The cars we've done are all over the world. This one is a DJ stand with a wireless remote that comes up out of the back seat. And that's actually Felix Baumgartner, who did the Stratos jump, doing his DJ impression. You know, so Felix has a little bit of fun, comes by, and we go and get a little bit crazy sometimes. The Pin Scours, which is a 6-wheel drive military vehicle built to patrol the Swiss Alps. They're built in like the 70s, 72, 73. And then what we did was to make them a little bit stronger, because the original engine was only 87 horsepower. It's kind of the baby sister to the Unimog. We ended up converting this over with a Volkswagen TDI, brand new Volkswagen TDI motor. So it's, instead of 87 horsepower, it's 150 horsepower, and instead of 10 miles a gallon, now it gets over 20 miles a gallon. So that's kind of fun. So we build the entire upper body and roll bars and generator box, and it has speaker pods that fold up out of the roof. The nickname of this is the RTPT, Ready to Party Truck. So they do stadium events with these vehicles. Kind of gives you a little bit of a shot. But, you know, we like to have fun with what we do. So one of the things, in between Man Flight 1 and Man Flight 2 for Red Bull Stratos, we got tasked from Pima Air and Space Museum. And they said, you know, we want you to build the world's largest paper airplane, because we want to inspire kids to think about engineering and aerospace. And so in between Man Flight 1 and Man Flight 2, we said, okay, well, let's build the world's largest paper airplane. So this is 45.5 feet long, 24-foot wingspan, weighed 800 pounds.
20 pounds of glue. And use a Sikorsky helicopter, take it up to 1,400 feet AGL, 45-mile-an-hour forward speed let go. So send it raised up to about 98 miles per hour forward speed. That's not a paper airplane unless it flies. It flew 0.93 miles in distance.
Oh my God.
And so it's pretty, you know, it's fun. It was really to inspire kids, and we ended up having to, it's all paper, there's no structure to it. So our goal now is to build a 50-footer and fly, you know, a couple miles, you know.
Because you can.
Because we can. I mean, it's you know, people bring me weird ideas, and they're like, you know, one thing that they've learned is I very rarely say no. And it's like, okay, let's think about this a little bit. So the point of why we're here is because, you know, you asked us to come because, you know, HP has really been a great partner for us, you know, as far as the application of the equipment, along with SolidWorks, who is really great, and the computing power as we go along, seeing the ability to quickly process large amounts of information. You know, I hate dinging other companies, but you know, one of the things about HP and about being able to do quick CAD processing and being able to do renderings on the fly for the client That's what it's all about. And HP being a super reliable, I've had some of my guys are like, okay, we're going to build this supercomputer. It's like, you know what? Just buy an HP. I can rely on it. Because so many times they go out and they build the computer, and it's just a letdown for me. You know, I get tired of looking at the hourglass. So, you know, from my heart, seriously, the thing about HP is it's reliable. It's consistent. You know, the quality and the power of what you do, especially with the new Z Workstations. I'm blown away with what we're able to do.
Good.
You know, they far outdo anything that a couple of my geeks tried to build in our shop, you know, and we're usually pretty good at building things.
Looks
So
like it.
it's like, I don't need to be building computers, we got paper airplanes to build, so. But
It's beautiful.
it really is fantastic being here, and we really appreciate all your
Absolutely.
hospitality.
Yeah.
The party last night was great.
Good. We're glad you could make it. Listen, I wonder, we talked a lot about the Z4
Yeah.
and the power that it has for doing all your analysis. What about mobility? What do you use a mobile workstation?
My biggest use for a mobile workstation is going out in the field with a laser scanner, going light scanners, and making sure I have all the data before I leave site. Nothing's worse than going back to Art and saying, I need to go back to Florida one more week, or go back out to New York from California.
Yeah, go because you
collect
want
anything I
to
miss.
for a trip, you know.
Not a good excuse, but I really like to be able to take the data, scan the item, post-process it slightly, be able to see, okay, what am I missing? What do I need better resolution on? Go back to the shop and be able to know I have everything I need. That way I can move forward with the project as fast as possible. And it's really also nice when you're out there in the field and the customer goes, you know, what are you doing with the scanner? And I can turn around, show them the laptop, the mobile workstation, and they see it and they see all the data I've just collected right there in front of them.
Instantly.
And sometimes they'll even bring me extra parts and go, hey, can you scan this for me? And I'll scan it, show them the data, and it really impresses them the fact that I can do it that quickly, turn around and show them that quality on site.
It sells them on who we are, for them to see that mobile workstation, to be able to see the interaction, and it convinces them that even doing something like restoring an old car, using new technology, we can step it up. We can bring it up another notch and really prove out the ability to fingerprint and recreate those pieces. So
Fantastic.
it's fantastic.
Fantastic. Good. Well, guys, it's been fantastic hearing your story. I'm dying to get out there to see your shop.
You got to
because
come.
All sorts of toys.
Yeah.
Fantastic. Thanks for joining us today.
Yeah.
It's been fantastic. All right. Thanks, John. Appreciate it.